matrix representation of a graph. So the first representation is an adjacency matrix. Suppose we are considering an undirected graph, which is a simple graph. Simple graph means no multiple edges and no self loop in a graph. And the graph is consist of n vertices v1, v2, v3 up to vn. The adjacency matrix of the graph is denoted as capital A with a subscript G, and it is a n cross n matrix whose elements are either 1 or a 0. The entry is 1 if ith and the jth vertex are adjacent, means if there is an edge between ith and the jth vertex. Otherwise, we will write it as a 0. For example, we need to write the adjacency matrix for this graph. Before that, we need to mention the ordering of the vertex. So the adjacency matrix with respect to ordering of the vertices A, B, C, D is, so just write the ordering of this matrix in a column wise and a row wise. So this entry is 1 if there is an edge between a vertex A and A. Or we can say that if there is an edge that starts and ends at A, then this entry is 1. Otherwise, it is a 0. So in this case, there is a no edge that starts and ends at A. It means this entry is 0. Is there is an edge that starts and ends at B? So since it is an undirected graph, if we say that there is an edge between a and B vertex, the meaning is same that it starts at A and ends at B, and same it starts at a B and ends at A, because in the undirected graph this edge is represented as A comma B or B comma A. The meaning is same. So if there is an edge between A and B vertex, then it is written as a 1, otherwise it is a 0. So is there any edge between A and C? So answer is yes. So write it over as a 1. Edge between A and D? Yes, write 1. Is there any edge between A, B and A? So answer is yes. So write 1. There is an edge from B to B? No. 0. Is there any edge between B and C? So answer is yes. Is there any edge between B and D? So no. Edge between C and A? Yes. Edge between B and C? Yes. Edge between C and C? No. Edge between C and D? No. Edge between D, A? Yes. Edge between D and B? No. Edge between D and C? No. Edge between D and D? No. So this is the adjacency matrix for this undirected graph. There is a second way to read this adjacency matrix, that is, if A is adjacent to any of the vertex, then in that case it is written as a 1. So now in this case, A is adjacent to B, C and D. So the corresponding entries are 1. Now take the B vertex. B vertex is adjacent to A? Yes. So B vertex is further adjacent to C, so corresponding value is 1, otherwise it is a 0. For the C vertex, C is adjacent to A and B, so corresponding column entries are 1, otherwise it is a 0. D vertex is adjacent to only A, so this entry is 1, otherwise it is a 0. Now there is a two remark in this case. We know that if there is an edge between a vertex A to B, we can read it as A comma B or B comma A. Aij entry is equal to 1 if and only if Aji is equal to 1, means its reverse position is also is equal to 1. So you can observe that this is the condition for the symmetric matrix. So in this case, we are getting A transpose is equal to A. So we can conclude that adjacency matrix of undirected graph is symmetric. Result 2, it say that for the simple graph, if the graph is simple, no self loop is there, means there is a no edge that starts and ends at the same vertex. It means the diagonal entries are 0. Moreover, you can observe that for the simple graph, the adjacency matrix is a 0, 1 matrix. So next case is a adjacency matrix of any graph G, but it is a undirected one. So in that case, there is a one change in the entry. Instead of 1, we will write a k, where k represents the number of edges between the vertex Vi and Vj. So in this case, for example, this is a graph H. So in this case, if you want to write the adjacency matrix with respect to the ordering of vertex A, B, and C and D, it is written as, so is there any edge that starts and ends at A vertex? No. Or you can go with the second procedure. A is adjacent to D and B. So means this entry is R1. Next is B is adjacent to A and D. So corresponding column entries are 1 and the rest are the 0. So C is adjacent to D. Now it is adjacent by 2 times. So we can write here as a C is adjacent to D 2 times. Next is D is adjacent to A, B, C, but it is also adjacent to D. Now there is a change over this column, third column, that is the entry will be 2, because there are 2 edges between the vertex C and D, and the rest of the entries are 1. Note that in this case the self loop is counted as a one edge. So we will write 1 over here because it represents the number of edges, not the degree of that vertex D. So result is, for the non-simple graph, the adjacency matrix G is no longer 0, 1 matrix. So this is not a 0, 1 matrix because there is an entry 2 over here. Next is the adjacency matrix for the directed graph. So let G is a directed graph with n vertices. The entry of the adjacency matrix is calculated in form of 0 and k, where k is the number of edges that start from the ith vertex and ending at the jth vertex. For example, the matrix representation for this graph is calculated as by taking the first ordering of the vertices. Before that, we need to calculate the order of adjacency matrix. So total number of vertices over here are 5. So the order of this matrix is a 5 cross 5. So after that, you can take the ordering of the vertex. So now we are taking the ordering of the vertices as A, B, C, D and E. The same order we have written in the row wise. So now check whether there is an edge that starts and ends at the A. So answer is no. So this entry is 0. So is there is any edge that starts from A and ends at B? Yes. So how many edges are there? That is 1. Now is there any edge that starts from A and ends at C? So answer is no. So this entry is 0. Is there any edge that starts from A and ends at D? So answer is yes. How many edges are there? That is equal to 1. Only one edge is there that starts from A and ends at D. Is there any edge that starts from A and ends at E? No. Is there any edge that starts from B and ends at A? So answer is no, because this edge starts from A and ends at B, but not starting from the B and ending at the A. So in this case, this is a 0. Now, is there any edge that starts from A and ends at C? Is there any edge that starts and ends at B? No. So is there any edge that starts from B and ends at C? So answer is yes. Moreover, it has 2 edges. So here entry is 2. Whether there is an edge that starts from B and ends at D? Yes. So number of edges are 1. Is there any edge that starts from B and ends at E? Yes. So entry is 1. Same you can go with this one, C, A. So any edge that starts from C and ends at A? No. Any edge that starts from C and ends at B? No. Any edge that starts from C and ends at C? Yes. So total number of edges are 1. So is there any edge that starts from C and ends at D? No. Any edge that starts from C and ends at E? Yes. So from D to A, one edge. From D to B, no edge. From D to C, 0. From D to D, no. From D to E, yes. Same for the E case. From E to A, no. From E to B, no. E to C, no. E to D, again no. And E to E, no. So this is the adjacency matrix for this graph with respect to ordering A, B, C, D, E. So it is very important to mention this one. So now the result is, you can check it. So the transpose of this matrix is not is equal to itself. So in general, adjacency matrix for the directed graph is not symmetric. Sometimes the directed graph is also called as a diagraph. So we can say that the adjacency matrix of a diagraph is not symmetric.